Hello everyone, and thank you for joining me. In this video, we are going to start our discussion of airframe or aircraft icing. Specifically in this video, we are going to start with the statistics relating to aircraft icing, and then also we are going to discuss induction icing.
So the statistics behind icing. What we're going to do is take a look at the different operating categories, Part 121, 135, and 91, and we'll see what kind of airplanes, what kind of operations cause icing accidents. As you can see, Part 121, icing is a very small factor in weather-related accidents. If you look at it, you can see on the pie chart it's only 0.8%, less than 1%. Of course, transport type aircraft are well capable of handling ice. Typically they fly at high altitudes that there's no icing conditions way up there at 30 or 40,000 feet. So usually not an issue except for climbing and descending. And then ground de-icing is a concern, and we'll talk about that later on. Part 135, you start to see icing becomes a bigger factor in weather-related accidents. 10% of all weather-related accidents are a result of icing under Part 135. Remember, 135 is air taxi and air charter. And then for Part 91 accidents, it's rather small, a little bit smaller than Part 135, and it's 7.1% of all weather-related accidents are caused by icing.
In 2004, the National Transportation Safety Board did an analysis of icing accidents, and the diagram that you see is one of several from a research paper. And the diagram here shows all of icing accidents for all the different types of operations, whether it be GA, Part 135, or Part 121. And it shows that general aviation, GA, has the highest number of icing accidents. As a matter of fact, they say that 80% of all icing accidents happen with general aviation aircraft. Notice that also from 1982 through 2000, the trend was downward for these 19 years of the study. And the other thing that you can see here also is that Part 135 varies quite a bit. Part 121, you see every once in a while there is an icing accident. This diagram shows the icing accidents that were fatal for both general aviation Part 135 and Part 121. And once again, you can see that general aviation has the highest percentage of accidents, in this case fatal accidents, that were caused by icing. But if you look at the previous slide and compare those, it indicates that the fatal accident rate is less than 1/2 of the total icing accident rate. As you would expect, most icing accidents occur during winter months, and that's what this diagram shows. It shows most icing accidents occur during January, February, March, even November and December. And there are very few icing accidents in June and July, but they still do occur. There's one or two there. This figure shows the phase of flight during which most aircraft accidents occur, and we can see that is during cruise, where 39.8% of all icing accidents happen. And that's followed by the takeoff and also approach phases of flight, which are approximately the same. This figure shows the spatial distribution of icing accidents, and it is obvious that most icing accidents occur in locations that have mountains, California, Alaska, Colorado, and even the Appalachians. And the reason for that is as aircraft pick up ice, their performance decreases and they can't maintain altitude and they will descend into the mountains. The other thing to notice is that a lot of icing accidents occur in areas where there's large bodies of water. So off the Pacific coast, California, Alaska, you tend to see a higher frequency of icing accidents. This figure shows the certificate that was held by a pilot that was involved in icing accidents. And the vast majority of icing accidents occurred with pilots that were had either a commercial or a private certificate. Not a lot of accidents occurred with airline transport pilots, ATPs, nor with student pilots. Student pilots typically don't encounter icing conditions. And of course, most pilots that were involved with an icing accident also held an instrument rating. This figure shows the total number of hours that a pilot who was involved in an icing accident had at the time of the accident. And specifically, this is for general aviation aircraft. You can see that the peak occurs about 500 hours and it tails off somewhat after that, drops off quite a bit above about 2,000 hours. But you can see also there's a secondary peak at about 10,000 hours. So what this indicates is that really no pilot is immune from an icing accident. This figure shows the total number of hours that a pilot involved in an aircraft accident had in the make and model of aircraft. And it shows that the pilots had very low time in that make and model of aircraft. What this indicates is that if you're new to an airplane and you're in icing, your chances of getting into an icing accident are much higher. This figure shows the total number of hours that a Part 135 or an air taxi, air charter pilot has when they're involved in an icing accident. And the diagram shows that there is a peak at about 2,500 hours and then another peak at about 10,000 hours. So what this indicates is that no pilot is really immune from icing accidents. This figure shows the total number of hours in the make and model of aircraft that a Part 135 pilot has when they experience an icing accident. And this is very similar to a figure that we saw previously for general aviation pilots. And the trend is similar in that very low time pilots with low time in make and model of aircraft tend to experience more frequent icing accidents. And what this indicates is pilots that are not familiar with the airplane tend to get into icing accidents. Here is data from another study. This one goes from 2000 to 2011 that the NTSB did on all weather-related accidents. And I wanted to focus or highlight the icing accidents. Specifically, they break down icing accidents into either structural or carburetor icing. And the data shows that carburetor icing has a higher frequency of causing aircraft accidents than structural ice. So not all icing accidents result from ice forming on the wings. It also is a result of ice forming in the carburetor. This video provided the contextual background that you need to understand icing accidents. It gave you all the statistics and what kind of aircraft and pilots are involved in icing accidents. In future videos, we're going to look more at the physics of ice and then also how to flight plan for icing. Hope you enjoyed this video.